Hello, I'm going to give a brief explanation of physical model of memory in Java. This is based on work by Professor Lewis at Illinois, but I wanted to emphasize a slightly different thing than she does in some of her videos, so I'll show you how I'm going to do it. So I'm going to start with integers. So if we declare variables in Java, like int a equals 42, int b equals 36, and then let's say int c equals a, I want to talk about sort of what happens, or a way to think about what happens. So when this code is executed, the declaration creates a variable, which I'm going to represent with this little card holder, and I'm going to label it with the name of the variable. So we're making three variables, A, B, and C, and each of them can hold a value, because that's what variables do. Variables are names for values, and the values actually live somewhere in the computer's memory. So I'm going to represent the values with things we put on these cards. So obviously in the real computer memory, values are stored in bits, but we can think of it as like writing out the bits, as writing the number on the card and sticking the card in the place that the variable is being held. So A gets the value 42, B gets the value of 36, and then C gets the value. To evaluate this whole expression, Java first has to evaluate A. And when we say evaluate a variable, that's just a fancy way of saying, look in the variable and see what the value is. But we don't take the value from A, we don't take it out of here and put it down here, we copy it. We look at the value and we make a new copy of that value and we stick it in C. After this point, there's no connection between A and C. So if I then add a line of code and say A equals 36, or I could have said A equals B, then that just means we're going to take the current value out of A and stick a new value in, which is 36. So that's probably not too surprising if you've learned about ints in Java, like you learned in Unit 1 of CS Awesome, if you're using that text. So now let's talk about what the equals comparison does. So we can compare A to B, and we can compare A to C. So I think we all know what it does with ints, which is it compares the values. So we just look at what's on the card, because there's nothing else to talk about, and say, is the value in A, 36, equal to the value in B? And yes, indeed, they are both 36. A equals C, or so that first one is true, right? This gives us true. Now, A equals C, we look at the value in A and the value in C, and they're different, so that comparison gives us false. So that should be not super surprising if you understand ints, and there's no great mystery there. So now, I want to switch things up a little bit and talk about what happens when these variables are not ints, but they are strings. So I'm going to erase all this, let's erase the whole thing, and so now we're going to declare and assign string variables named A, and we'll call that hello, and a string variable named B, which is going to be a new string, and we'll actually just pass A in as the value to this constructor, and then finally we'll say string C equals A, just like we did before. Okay, so strings are big. They don't fit in these holders because they could be arbitrarily large. Right? This card just has hello on it, but it could have the complete text of War and Peace. So that's got to go somewhere else. So I'm going to make a table over here and call that objects. And this is where we're going to put all the objects that we make. Sorry, I need a magnet here. And so when we make a new string, or the Java makes a string because of that string literal, it's going to go in our object table. We'll stick it there. And we'll call this object number 1, just so that we can refer to it. And so then what is the value in the variable? The value in CS Awesome, we talk about the difference, and all Java terminology talks about the difference between primitive values like ints, like we just dealt with, and reference values. And strings are the first reference type that we talk about in the AP curriculum. And so what a reference is a value that tells us where the object is. And Professor Lewis likes to visualize that with a connection between the reference and the object. I think that's a good idea. So we're gonna come over here and use this little conspiracy theory board red yarn to show that this value, object 1, is referencing this particular object in memory. We don't really need the yarn because the value tells us where it is in our objects table. So then, when we execute the line string B equals new string, new means what it says. It's a new string. It can't be any existing string. So we're guaranteed to get a new string. This one happens to have the same text. In fact, it took the text, it went and made a copy of that text, and now I have a new string that I want to stick in my object table, and I'll call that object number 2, which means that I need a different value to put in B, namely object number 2, a reference to object number 2, and we can illustrate that with a new piece of yarn and say object 2 is referencing this object. And so now we have, is there a little, hard to see which is going where, but one going to object 1 and one going to object 2. And now finally, string C equals A is actually the same thing happens. We don't need the yarn. We don't need to follow any of this yarn and look at these objects. We do exactly the same thing we did with an int, which is we look at this value, we make a copy of it, which I happen to have ready to go, and we just stick that copy into the variable C. So now A and B and C, and we can, for marking things out, oops, I can get, another piece of yarn here, and tangle it up, and point object 1 just to show that we now have 2 references to the same object, object number 1, which we can also just tell by seeing that there's 2 values that are references to object number 1. Okay, so now we have our same quality comparisons as before, A equals B and A equals C. And again, just like when we copied the value of A into the variable C, the comparison works exactly the same in that it only cares about these values. So is A equal to B? In this case, since I haven't reassigned anything, A is object 1, B is object 2, those are different values. I don't need to do anything with the yarn to tell that these are different values. A equals C, object 1, those are the same. So this time, A and B are false, and A and C are true. And that's not, sorry, due to any difference in the strings, it's just because I think previously I reassigned A somewhere in there. Okay, so now strings, so sometimes people say equals doesn't work for strings. That's true in the sort of sense that usually what we want when we ask if 2 strings are equal is not, are they literally the same strings, but we care about what's actually on this card. Is it hello and hello? And so that's what the string equals method is for. So now we can say A equals B, and this is a whole method call, and it is going to, I'll even show you, we can draw sort of the frame of what happens when we call equals. This box represents equals, and there's 2 variables involved. One is the variable this, which exists in every instance method and is the name for the object on which you invoked the method, and another variable whose name we don't know, but we know there has to be at least one parameter in this method because it takes an argument here, And so we'll just call it other, which is usually what people call it in their equals method. And that means we have two new variables. And method calling works kind of exactly the same way as assigning a value to a variable. We're kind of assigning the value to the parameters. So A is the same value as, we take the value of A and make that the value of this, and then we evaluate this expression, which just means look up the value of B, and we get another copy of object 2, that reference, and stick it in here. And again, we can use the yarn just to show where things are going, and in this case, we actually kind of will need that. So now for the moment, we have yet a third reference to object number 1, and a second reference to object number 2. Got a lot of yarn going on here. And now equals, the code actually has to follow. To do its work, it needs to follow the yarn. These yarn are like the dot operator, or at least this one is the dot to get to the underlying data. So inside equals, and inside the string class, there's instance variables that actually hold this data. It's actually an array of characters, which we don't talk about in the AP curriculum, but it's under there. And the equals method has code that follows these two references to get to these actual objects, and then walks through these characters and makes sure that they're the same. If they are, then it returns true. And in this case, it will. So this will return true because those two strings have the same contents. And at that point, once the method has returned, this all goes away. We can take these off, stick it here. These variables go away, and this whole method disappears. So the thing that I really wanted to emphasize is this idea that the reference values are at root very simple. They're just values, just like the values of ints or booleans or doubles. And when we're doing things like comparing them with equals equals or assigning them, it works exactly the same as it does with primitive types. The difference is that you can also dereference using the dot operator to get to the actual objects that live in memory. And then the last thing that happens is, that I want to show you, is that we can, let's say after we've set C to A as object 1, actually what do I want to do? Object 2, B is object 2. I want to reassign B to a new string, goodbye. So that's a whole new, definitely a new string. It's not the same content, so it's a totally new string. So we're going to make it from whole cloth, go to the bit mines, get some more bits, make a string, stick it in our object table. That is going to be object number 3. And this assignment says, okay, first we're going to remove the reference to object number 2. And what just happened is actually kind of what happens in Java. There is no more reference to that object because we're taking this one away, and that card fell off the board because there's no reference to it. That is what in Java we call garbage. It is memory that is no longer usable by the program, and so now this slot in memory is available for some future object to use. But in the meantime, we have a new value, and the reason I stuck these on with this little yellow magnet was just before I make the reference, it might be a little hard to see that, I need to keep it on the board just long enough to make it. And so now we've stuck object 3 as the value in B, and it references this thing, and that's keeping it alive. So now after all of this has happened, we have 2 distinct objects that also have distinct contents. So now A equals B would be false because B is both a different object and has different contents. So that hopefully explains a little bit about what equals equals does and the difference between it and the equals method on strings and all other objects. And so hopefully that is helpful to you. Thanks very much.